Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and on this channel we cover all things general chemistry related. On this video we're going to be covering chemical symbols and the atomic symbol. Let's get started. In the previous video we discussed and introduced the atomic number. Remember, the atomic number is equal to the total number of protons in the nucleus, and that's how we're going to be identifying which element we're talking about. And we also discussed how for a neutral atom, that the electrons, the number of electrons, would be equivalent to the number of protons. So from our periodic tables, it's very easy to see what the number of protons or electrons could be. Now, the other thing we discussed is this idea of the mass that's attributed to an atom. The mass number within an atom is equal to the sum of the protons that are found in an atom plus the neutrons. Remember, we don't consider the electrons in that mass number because the mass is so small, it's essentially negligible. It's not contributing at all. And so when we report or show the element or the symbol for an element, we often do so in a manner called the atomic symbol. Now, your atomic symbol is going to be a shorthand way for us to actually summarize all of this information. The atomic symbol has three main parts, and then oftentimes there could be a fourth part added. So in the atomic symbol, you're going to be writing the element symbol. And again, if you look on your periodic table, you'll see a letter or two letters associated with the different elements. Remember, the first letter is always written as a capital letter, and then the subsequent letters are written in lowercase form. And so then we would also include at the top the mass number of the element. Again, the mass number is going to be equivalent to the number of protons plus the neutrons. And if you're looking at the periodic table, you would simply take that number that has decimal places associated with it and round it to the nearest whole number to get your mass number. And your atomic number, again, represents our protons. We can, again, extrapolate the information about the subatomic particles based on the numbers that we see present. Remember, your atomic number is the number of protons. The mass number is equal to your protons plus neutrons. And if we wanted to figure out the number of electrons, we would first look and see if it's neutral. If there is no charge associated with the atom, then the number of protons would equal the number of electrons. And if we're dealing with something that has a charge, something called an ion, then we would adjust the number of electrons based on the charge that we see represented. So occasionally you may see a charge written up here in the top corner if you're dealing with an ion. Very important to remember, protons are how we define an element. If we change the number of protons that are found in an element, then you're changing, in theory, which element you're describing. So protons are fixed. We're going to learn that the number of neutrons and electrons can actually be varied. So let's try a few examples. On this slide, it says, what element has 17 protons found in the nucleus? So remember, 17, that represents the same as our atomic number. So we would look at our periodic tables and find which element has an atomic number of 17. When we do so, we can see that chlorine would be our desired element. Again, make sure you're looking at the whole number found in that cell, that chemical symbol cell, and not the number with the decimal points. Okay, great. Next question, it says, what element has an atomic number of 12? So atomic number 12, well, that would coincide with our magnesium, which has 12 as its atomic number. Okay, the next question says, a neutral atom contains 7 electrons. What is the atomic number of the corresponding element? Now, there's a key word here that we really need to pay attention to because the only information we know right now is that there are 7 electrons. However, it also states that we're dealing with a neutral atom. So because we're dealing with a neutral atom, that tells us that our number of protons would equal the number of electrons. So therefore, we must have 7 protons. If we have 7 protons, that is where we can about nitrogen. So you must take that process, that step process, to make sure that you're actually identifying the element based off the proper number. Okay, so now we can also work a little bit backwards. If we're given information about the atomic number and the number of neutrons, we should also be able to develop what the atomic symbol would look like. Remember, an atomic symbol has those three parts: the element symbol, the mass number written up top, and then the atomic number written on the bottom. And so if we look at number 1, hydrogen, well, if we look on the periodic table, we see that the element symbol is capital H. And we're told that we have an atomic number of 1, so that will go on the bottom, and 0 neutrons. So remember, the mass number is equal to my protons. Remember, the mass number is equal to the protons plus the neutrons. So in this case, I would take 1 plus 1 and end up getting a total of 1 up top. For number 2, helium, we would write the symbol as He and then fill in the numbers accordingly. On the bottom is where we'd put the atomic number of 2. On the top is where we would add 2 plus 2 to get us 4. Notice the second letter in that symbol, the E, is lowercase, and you always write all chemical symbols with the first letter being capitalized, the second letter being in lowercase. Number 3, we have lithium. We would put 3 at the bottom as the atomic number, and 4 plus 3 at the top, which gives us 7. Next, we have beryllium. Symbol is Be. On the bottom would be the number 4. Up top, the number 9. Do one more set. Oxygen here is shown for us. So oxygen has a symbol of O. The atomic number would be 8. The mass number would be 16. Make sure when you're writing chemical symbols, you always write both numbers as whole numbers. The numbers that are displayed will never have any decimal points present. For number 2, carbon, we have carbon. Up top, we would put 6 plus 6, which is 12. On the bottom would just be 6. Number 3, be careful with this one, because all the previous ones we've seen, the symbol started with the letter that the element starts with, but potassium and a few others are a bit of an anomaly. So if you look at the symbol for potassium, potassium is actually K, and on the bottom, we would put its atomic number of 19, and on the top, we would put its mass number of 39, and we're getting that by simply adding the two numbers together. And then last but not least, we have iodine, symbol I. On the bottom, we would put 53 as the atomic number. Up top, we were going to add the atomic number plus those neutrons, and that's going to give us 127, which goes on top. Again, all whole numbers representing the protons plus the neutrons. Now, let's put all that information together. We should be able to fill out this chart based on the information provided. And you'll see different rows contain different amounts of information, but we should be able to figure out the information based on what we have. As we're completing this table, we're going to assume that everything is neutral, okay? So these are neutral atoms, okay? So up first, if we have a neutral atom that has 6 protons and 7 neutrons, well, we would assume that the electrons should be 6 because, again, we're dealing with a neutral species. Protons equal electrons. The atomic number in this case would be 6 as well because that's equivalent to the number of protons. The mass number would end up being 13, and that's from adding our protons plus our neutrons. And so based off of this, remember the atomic number or the protons, that's how we identify the element. In this case here, we would be dealing with element C, carbon, with 6 on the bottom, 13 on the top. Now you may notice this number looks a little different than the previous one we showed a few slides ago, and that's because this actually represents an isotope. And I'll be talking about isotopes in a later video. All right, next row, we see that we have 42 electrons. So 42 electrons means that we would also have 42 protons if we're dealing with a neutral species. To find the number of neutrons, we would need to take 96 minus 42, and that will give us 54 neutrons. Our atomic symbol would also be 42. And when we fill this in, we would be dealing with the symbol MO, molybdenum. And on the top, we would have 96. On the bottom, we would have 42. Up next, we are given the atomic symbol in this row. So we now need to deduce all the information about the subatomic particles. So our protons would be equal to the number of the atomic number, which is on the bottom. So that would be 13. The protons in this molecule, the protons in this atom would be equal to 13. The number of electrons, if we're dealing with a neutral species, would also be 13. The number of neutrons we're going to get by taking 27 minus 13, which gives us 14. Our atomic number would be 13 because it's the same as protons, and our mass number would be 27. Last but not least, we can fill out this final row. So again, we have 55 as the atomic number, which means we would have 55 protons. If we're dealing with a neutral substance, we would also have 55 electrons. We would also have 55 electrons. The number of neutrons would be equal to the mass number, 133, minus 55, which would give us 78. And so when we fill that all together, put that all together, we would end up with 133 on the top, 55 on the bottom, end up with 55 on the bottom. And when we look that up, what symbol that is associated with, that would be cesium. This video helped you understand everything about subatomic particles. Check back in for more videos related to atoms and elements. Be sure to subscribe, comment, and like, and let me know what type of videos or other material you'd like to see. Have a great day. See you guys soon. Bye.